Mangaru's Tutoring Services Mathematics Classes. Revision class number 4. You can feel free to pause the video, attempt the questions, and then follow along with the solutions. Number 1. Write the number above in words. 956,207 9/10 and 8/100. Part B. Write the number above in expanded notation. 9 times 100,000 plus 5 times 10,000 plus 6 times 1,000 plus 2 times 100. Now know that we can put 0 times 10 or we can leave it out. Next, 7 times 1. After the decimal point, this 9 means 9/10 and this 8 means 8/100. So that's 9 times 1/10 and 8 times 100. Part C. Round off the number above to the nearest tenths. So they are talking about this number on top. The tenths number is the 9. So we look at the number on the right of the 9, which is the 8. Since the 8 falls in the category of 5 or more, we must add 1 to the 9. 9 plus 1 will give us 10. We will add 1 to the 7, which will give us 8. And all the numbers on the right of the 8 will become 0. All the numbers on the left of the 8 we will keep. So the answer is 956,208. C. Part 2. Round up the number to the nearest millions. So again, we are talking about the same number above. Here we can see that this number only goes up to hundreds of thousands. So how can we round it off to millions? Well, after hundreds of thousands, we go to millions. So we can use a place filler, 0, for the millions, since there are no millions. Since the 9, the number on the right, is more than 5, we add 1 to the millions. So this becomes 1 million. And we change all the numbers on the right to zeros. So the answer is exactly 1 million. If you leave the decimal numbers out, the value will be the same. So that's also correct. Part D. State the value of the 0. The value of any 0 would be 0. It doesn't matter where it's placed. In this case, it is placed in the tens column. So 10 times 0 is equal to 0. If it was placed in the hundreds of thousands position, this would have been 100,000 times 0, which will still give you 0. So remember, value is how much the digit is worth, and place value is the position that the digit is placed in. Part E. State the place value of the 5. So the 5 is in the tens of thousands position or column. So the answer is tens of thousands. So it's better to write that in words. Don't write 10,000, you will get it wrong. Two, state the LCM of 12 and 16. What does LCM stand for? This stands for lowest common multiple. Just cleaning something off the screen. Okay, great. Lowest common multiple. So what we will do is write out all the or sum of the multiples for 12 and 16 until we find a common multiple. So the first common multiple will be the lowest common multiple. So what are the multiples of 12? The multiples of 12, 12 times 1 is 12, 12 times 2 is 24, and so on. Right? Let's list some of the multiples of 16. 16 times 1 is 16. 16 times 2 is 32. Right? So we can see here that 32 occurs for both the multiples. So this will be the lowest common multiple. Part B. Write all the prime numbers between 0 and 30. What is a prime number? A prime number is a number which only has two factors, itself and 1. So remember, 1 is not a prime number. So the first prime number is 2, then 3, right, up to 30, so we stop here. Next, put the following in ascending order. (33 1/3%). Remember, 33 1/3% is simply 1/3. Right? Which one is greater, 1/3 or 0.3? 1/3 is the same as 0.33, where the 3 is recurring. So the smallest number which comes first in ascending order will be this, followed by this, then 3 1/3, then 30. Three. State the name of the solids with the following properties. 6 edges and 4 vertices is a triangular based pyramid. One face, I have a typo here, so that's supposed to be sphere. Two faces, a cone. 3 faces, a cylinder. 4 faces, a triangular based pyramid. 5 faces, a triangular prism. 6 vertices, a triangular prism. 4 triangular and 1 square face, a triangular based pyramid, and 9 edges, a triangular prism. For those of you who don't have the question paper, you can feel free to pause the video now and attempt the questions. For part A, name the following triangles. So these dashes means that all the sides are equal. So this is an equilateral triangle. For the second one, these two sides are equal, so we call this an isosceles triangle. For part C, we know that if all the sides are different, then all the angles will also be different. So this is a scalene triangle. Number 5. Name the following lines. So this here is a pair of parallel lines because they both go in the same direction and they don't meet. These two lines meet at 90 degrees, so they are perpendicular. This is a horizontal line, and this is a vertical line. Number 6. They simply asked us to name the quadrilaterals, but I will do a little more than that. So this is a square, because all the sides are the same. These dashes here indicate that all the sides are the same. This here tells us that all the angles are 90 degrees. These are the 4 lines of symmetry in green. This here tells us that this is a pair of parallel sides, and this is also a pair of parallel lines. B, a rectangle. 4 right angles. Opposite sides are equal, 2 long equal sides and 2 short equal sides. Opposite sides are parallel, and there are 2 lines of symmetry. C. A trapezium is defined as a quadrilateral that has 1 pair of parallel sides. The trapezium comes in 3 different designs, or 3 different types. So that is 1. In this one we can see there are no lines of symmetry, no equal angles, and no right angles. T, a kite. 1 line of symmetry, 1 pair of opposite angles being equal, adjacent sides are equal. E, a parallelogram. A parallelogram is similar to a rectangle, but instead it has been shifted where the angles are not 90 degrees, but the opposite angles are equal. Here we have 2 acute angles and 2 obtuse angles. Opposite sides are equal and parallel, and there are no lines of symmetry. Rhombus. 2 lines of symmetry. Opposite angles are equal, 1 pair is acute and 1 pair is obtuse. All the sides are the same length. G. This is a trapezium because it has 1 pair of parallel lines. This particular one has 2 right angles. And the last one is also a trapezium. We have 2 of the base angles being equal, one line of symmetry, and of course one pair of parallel sides. So all of these numbers here were spoken about in describing the quadrilaterals. So you can pause the video and check over the answers. Number 7. So we are going to name the polygons, and then we have some quarter turn questions. So at this point you can pause the video and try the questions. Six-sided polygon. This is a regular polygon. It's called a hexagon. These are all regular polygons. 6 sides, hexagon. 5 sides, it's called a pentagon. 8 sides, it's called an octagon. And 7 sides is called a heptagon or septagon. Alright, let's talk about number 8. Number 8. How many quarter turns from H to C? So we are talking about in this image here. If we must pass E, so it means that we must go this way. So how many quarter turns are you all seeing? Right, whether it be internal or external. So that's 1, 2, 3, 4. Part B. How many quarter turns from A to G if we must pass D? So that's 1 quarter turn, 2 quarter turns, 3 quarter turns, 4 quarter turns, 5 quarter turns. 1, 2, 3, 4, 5. Part C. If we made 3 quarter turns in a clockwise direction and ended up facing south. So C and D are separate from A and B. It's not related to the figure above. If we made 3 quarter turns in a clockwise direction and ended up facing south, what direction did we start? So let's draw our 4 cardinal points. So we ended up facing south, and we made 3 quarter turns in a clockwise direction. So what we can do, we can move in the opposite direction to determine where we started. So that will be 1 quarter turn, 2 quarter turns, 3 quarter turns. So it means that we started west, right? So that's 1 quarter turn, 2 quarter turns, 3 quarter turns. So the answer is west. Part D. If we start from west and make 6 quarter turns in a clockwise direction, which direction will we be now facing? Alright, so let's use the same cardinal point system. So let's start from west and make 6 quarter turns. 1, 2, 3, 4, 5, 6. So now we are facing east. So the answer is east. Number 9. Here we have some patterns questions. If you like, you can pause the video and try the questions before we go through the solutions. (9A). 90, 88, 84, 78. So we can see that the numbers are slowly decreasing, or decreasing in an accelerated manner. So to get from 90 to 88, let's try subtraction. Minus 2, yes. Then to get from 88 to 84, we have to minus 4. And then from 84 to 78, we must minus 6. So we are seeing that we are decreasing by 2 more every time. So the next step will be to minus 8. 78 minus 8 will give you 70. And 70 minus 10 will give you 60. So let's look at the next pattern. This one, we can see that the pattern is increasing. Let's try addition. 11 plus 1 will give you 12. 12 plus 3 will give you 15. 15 plus 5 will give you 20. And 20 plus 7 will give you 27. So we can say that we are adding increasing odd numbers, or we are adding numbers starting from 1, increasing by 2. So after 7 will be 9, or 7 plus 2 is 9. So 27 plus 9 will give us 36. And 36 plus 11 will give us 47. Right, so of course we're not going to leave these numbers above, right? Next we have 1, 4, 9, 16. So many of you will recognize that these are squared numbers. 1 squared, or 1 times 1 is 1. 2 squared, or 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 times 4 is 16. So next we will have 5 squared, which is 25, and then 6 squared, which is 36. Part D. So the numbers are increasing. So let's try addition again. 1 plus 2 will give us 3, or 3 minus 1 is 2. 3 plus 3 will give us 6. 6 plus 4 will give us 10. 10 plus 5 will give us 15. So we are seeing a pattern here. We are adding one more to each number. 15 plus 6 will give us 21. And 21 plus 7 will give us 28. E. So we are seeing decimals, fractions, percent. Decimal, fraction, percent. So we are going to keep that pattern, but the numbers seem to be increasing as well. 0.25, this is the same as a quarter. So from a quarter to a half, we increased by 1/4. Half to 75%. 75% is also 3/4. So again, we increased by 1/4. 3/4 to 1. Again, we increased by 1/4. So we are increasing by quarters, but we are going from decimal, fraction to percent. We are changing among the three. So after percent, we have decimal and then fraction. So 150% plus 1/4 will give you 175%, or 1.75. And 1.75 plus 1/4 will give you 2. Next one, F. So let's see. We are increasing here, so that's plus 1. And then we are decreasing. 101 minus 98 will be 3. So we are minusing 3. Then again we are adding 1. Then again minusing 3. Then again adding 1. then minusing 3. So we can see a pattern developing here. We must then add 1 and afterwards minus 3. 94 plus 1 is 95. 95 take away 3 will give you 92. G. So we can see these numbers increasing, but it's increasing by a very large amount every time, or by an increasing amount every time. So 2, can we use plus 2? Let's see how that will work. Then what? Plus 4 and plus 8. Okay, so that may not be the best approach. The pattern here is 2 times 1 is 2, followed by 2 times 2. So what we are doing actually is multiplying the first term by 2, or the previous term by 2. So the first term is 2, the second term is that last term times 2, so we get 4. Now 4 times 2 will give you 8, and 8 times 2 is 16. So the next one will be 16 times 2 will give you 32, and then 32 times 2 will give you 64. So here we have some circles with some cardinal points. North, northeast. So we can see we turn clockwise by half of a quarter turn, or 1/8 turn. Then we went from northeast to southeast, so that's a quarter turn. And then from southeast to south, so that's 1/8 of a turn. And then from south to west, so that's quarter turn. And then from west to northwest, so that's 1/8. So we can see we are making a 1/8 turn, then a quarter turn, then a 1/8 turn, then a quarter turn. Right? So next we will have a quarter turn and then a 1/8 turn. So from northwest we must make a quarter turn, which will bring us to northeast, and from northeast we must make a 1/8 turn, so that will bring us to east. Okay, so we have the last one below, which is the most challenging of all of them. So what we will do is I will minimize the previous question, so that we get more space to work out I. Okay, so we are seeing a pattern here. 2 boxes, we have lines connecting dots, followed by 4 boxes, followed by 6 boxes. So we can see an increase, horizontal increase of 2 boxes. Find how many boxes are in the 15th pattern. So this here is the first pattern, this here the second pattern, and this here the third pattern. So how can we determine the number of boxes in each pattern. So we can put B here. Boxes is equal to first pattern, number 1 times 2, in the second pattern again times 2, and in the third pattern again times 2, right? So 1 times 2 is 2 boxes, 2 times 2 is 4 boxes, 3 times 2 is 6 boxes. So all we need to do is say 15 times 2. Part B. Work out how many corner or dots are in the 8th pattern. So let's see what kind of pattern we can see for the dots. So I'm going to erase this. Actually, we can leave that. Let me write it here. So let's count the dots for the first pattern. 1, 2, 3, 4, 5, 6. So let's write that down, 6. The next pattern has the same 6 but plus 1, 2, 3. So 6 plus 3, let's make note of plus 3, is 9. The next one will have the same 9 but plus 3 again. So that's 9 plus 3 is 12. So we can see a pattern with the dots. For the next pattern, it's increasing by 3. So how do we determine the dots for the 8th pattern without having to draw all of the patterns and count, or without having to draw the 8th pattern and count them? We must be able to come up with a faster way, because this 8th pattern is a couple of patterns away. Alright, so we started with 6, right? And we're adding 3 every time. So we can say the 8th pattern times 3, right? Because here we have 3 more every time. The only difference is we started with we have an extra 3 to start with, right? We started with 6 and then we keep adding 3 going forward. So it's 8 times 3, and then we have, so that will give you 24. And we must add 3 for the extra 3 that we started with. Part C. Work out how many lines between the dots in the 6th pattern. So again, yes, we can draw it out and count it, but let's see if we can figure out a way to determine the amount of lines without drawing the pattern. So let's count the amount of lines in the first pattern. So 1, 2, 3, 4, 5, 6, 7. So let's write that down. Followed by, we have the same 7 here. We're going to add 1, 2, 3, 4, 5. So that's 7 plus 5 is 12. Then the next one, we have the same 12 here. Then we're going to add 1, 2, 3, 4, 5. 12 plus 5, 17. So we can see that for the next pattern, we are continuously adding 5 to get the next pattern. So if we are talking about the sixth pattern. So we start with 7, and then so there are 5 more patterns, sorry, to get to the sixth. So for every one of the 5 patterns we must add 5. So 5 sets of 5 would be 5 times 5. So that would be 7 plus 5 5s are 25, which will give you 32. So that's 32 lines. Number 10 to 12. You all can try the questions before we work them out. As soon as you are finished, you can unpause the video and let's correct it. Number 10. Maya will be 41 years in January 2022. In February 2020, she was twice or 3 times her son's age. Part A. In what year was her son born? So firstly, let's work out Maya's age in 2020. So that's 2 years before. So she is 41 years in 2022. 2 years earlier, she will be 2 years younger, which is 39 years. And 39 years is 3 times her son's age. So 39 divided by 3 will give us her son's age in 2020. So her son is 13 years old. In what year was her son born? So in 2020, her son was 13. So we simply take away 13 from 2020. Part B. How old will her son be in 2030? So in 2020, he's 13 years. So 10 years ahead, he will be 10 years older. So 13 plus 10 years will give us 23 years. Number 11. What is the modal fruit? So let's see what's happening here. We have a list of fruits: mangoes, cherries, bananas, plums, right? These are the students' favorite fruits. So Andy has 2 favorite fruits, mango and banana, and all the other persons we can see their favorite fruit or fruits. What is the modal fruit? So what fruit is liked the most among the students? We can see that all the students like mango. So mango is a modal fruit. What percent of the students like more than 3 fruits? So more than 3 will be 4 or more. We only have 4 fruits, so it will be the persons. We have to check the persons who like 4 fruits. So it's only Cindy. Only Cindy likes more than 3 fruits. So that's 1 person out of 5 persons. So that's 1/5. And what fraction is 1/5? Well, we can simply multiply 1/5 by 100 to make that fraction into a percent. 5 into 5, 1. 5 into 100 is 20. So that's 20% of the students. Part C. What fraction of the students like cherry? Let's see how many students like cherry. Only one person like cherry, and that's Cindy. So that's 1 out of 5 persons again. So that's 1/5 of the students. Number 12. There are 3 classes in a school. Each class has 5 boys and 5 girls. The students are going on a field trip to the cinema. Each class will be accompanied by 1 teacher. Each student must be accompanied by 1 parent. How many 10-seater maxis are needed to seat all persons? So in total, 5 boys plus 5 girls will be 10 students and 3 classes. So that's 10 times 3 is 30 students. For every class, there will be 1 teacher, so 3 classes will be 3 teachers. And for 30 students, there will be 30 parents. So what we can do is add up these amounts. To determine the total amount of persons that needs to go with the maxi. So that's 30 and 30 and 3, that's 63. Each maxi holds 10 persons. So we can divide by 10. 10 into 63 will give us 6, remainder 3. So do we use 6 maxis or do we use more? Right? Well, we can't simply leave the 3 persons at home or at school. So we must use an additional maxi. So we round up. So that will be 7 maxis or 7 maxi taxis. Part B. The theater had 5 rows of 18 chairs. What percent of the theater did the students occupy? So let's determine how many chairs in total. So 5 times 18, that's 90. So that's 90 seats or 90 chairs. And we know that there are 63 students. So let's put it in terms of a fraction first. What percent of the theater did the students occupy? So that's 63 seats they filled out of the 90 seats. Right, let's reduce this fraction. 9 into 63 is 7. 9 into 90 is 10. We can multiply this by 100. Cancel 1 and 0 on top, put 1 and 0 below. 7 times 10 is 70. So that's 70%. There is an error in number 13, so we'll be focusing on 14 and 15. Please attempt the questions before going through the solution. Number 14. 17 street poles are evenly spaced 8 meters apart from the start to the end of the street. what is the length of the street? So we need to determine the total length. Total length is equal to the spaces, or the number of spaces, multiply by the spacing, the distance between two adjacent poles. So we have to determine the number of spaces. We were given the number of poles. The number of spaces is equal to the number of poles minus 1. And this is for objects such as poles and posts and flags and stuff that is in a straight line or not in a perimeter. So this will be 17. They gave us the number of poles to be 17 minus 1, which is 16 spaces. And so now we can put that into the formula. So what is the spacing? The spacing is the distance between two adjacent poles. So the first and the second, third and fourth, etc. So the spacing was given to be 8 meters. So the number of spaces 16 multiply by the spacing, which is 8. And this will give us 128 meters. Now for objects in a perimeter, it's a little bit different. So here we have a question in which we are dealing with a perimeter. Number 15. 50 cones are evenly spaced around a square field of area 100 meters squared. What is that should be distance between any two adjacent poles? Right, so the area wouldn't really help us to determine the cones or the spaces or anything like that. We need to determine the perimeter. From the area, however, we can determine the length of one side and then the perimeter. So let's start with that. The area is given to be 100 meters squared. That's of the square. We know area is equal to side times side. So some number times itself will give you 100. Or in other words, side is equal to the square root of the area of the square. So the square root of 100 will give you the length of one side, which is 10 meters. The perimeter of the square is equal to side times 4, which is 10 times 4, which is equal to 40 meters. So now that we have the perimeter, we can determine the spacing. The spacing is the total length, in this case that's the perimeter, divided by the number of spaces. So for objects in a perimeter such as this question, the spaces, the number of spaces, is equal to the number of objects such as the cones. So the spaces between the cones is equal to the number of cones, and we know that that is given to be 50. So what is the formula for spacing? Let me mention that again. spacing or the distance between any two adjacent cones is equal to the total length, which we worked out to be the perimeter, divided by the number of spaces, which we already determined is 50. It's 50. Okay, so total length is equal to 40 meters and number of spaces is equal to 50. So 4/5 is equal to 0.8 meters, or 80 centimeters, and that's your answer. 0.8 meters or 80 centimeters. Numbers 16 to 20. Please attempt the questions before we begin. Number 16. 2/7 of Kim's money is $28. How much is Kim's total money? So there are more than one ways that we can work this. Some persons say, well, if 2/7 is 28, then we can divide 28 by 2 to find 1/7. And then we multiply by 7 to find 7/7, or the total. Fourteen times 7 is 98. Or we can do it this way, where we say 2/7 is 28. So we flip 2/7, we get 7 over 2. We multiply by what is equal to, which is 28. 2 into 2, 1, 2 into 28 is 14, and we get the same answer, 98. So the answer is $98. Number 17. Dylan lost quarter of his pencils and gave away a third of the remainder. If Dylan kept the rest, which was 12, then how much did he have at first? So he lost quarter and he gave away a fraction of the remainder. So let's begin by finding the remainder. So the remainder is 1 whole, take away the quarter, which will give us 3/4. So what he gave away will be a third of the remainder, which is a third multiplied by 3/4, and this is 1/4. If Dylan kept the rest, which was 12, then how much did he have at first? So after losing a quarter, he remained with 3/4. Let me get some water. Right. After losing 1/4, he remained with 3/4. And then he gave away a quarter. So let's see how much he has now. So the rest will be 3/4 take away the quarter that he gave away, which will leave us with a half. And they're telling us that that half is equal to 12. Because it said the 12, the rest which was the 12. So if half is equal to 12, what is the total? Total will be the 2 halves, or 2 over 1, we flip the fraction and multiply it by what it is equal to, and we'll get 24. So the total is 24 pencils. Number 18. In a class, there are 3 times as many girls as boys. There are 44 students in the class. What fraction of the students are boys? So we can see that girls and boys are not evenly distributed or equally shared in the class. So let's put it in terms of boxes. So there are 3 times as many girls as boys. So seeing that boys is less, we put boys, abbreviated as B, is equal to 1 box, and girls will be 3 times 1 box, which is 3 boxes. So in total, 1 box plus 3 boxes is equal to 4 boxes, or we can put it as 4 times box. So 4 boxes is equal to 44 students. But before we work out 1 box, let's talk about part 8, the fraction. What fraction of the students are boys? So boys is 1 box out of the total, which is 4 boxes. So 1 over 4 is 1/4. How many girls are there in the class? So let's determine the value of 1 box, and then we can determine the value of the girls. So here we are seeing that the total is 4 boxes. So 4 boxes is equal to the 44 students. So 1 box, we can do reverse calculation or work backwards. 4 times some number is 44, so we can say 44 divided by 4, and that's 11. So 1 box is 11, and girls is equal to 3 boxes, so that's 3 times 1 box, or 3 times 11, which is equal to 33. So the answer is 33 girls. Alright, so let's put the answers on top. So boys is 1/4 and girls is 33. Number 19. Sean bought half kg more flour than Dina, but 70 grams less flour than Tristan. Altogether, they bought 7.7 kilograms of flour. How much flour did Dina buy? So I will work it in terms of kilograms, everything in kilograms, seeing that most of the numbers are already in kilograms. So let's try to figure out who got the least amount. So Sean got more than Dina, and Tristan got more than Sean. So Dina got the least amount. So Dina, we'll use D for Dina, is equal to box. Sean, S, is equal to box plus half kg or 0.5 kg, and Tristan is equal to the same amount that Sean got, but 70 grams more. So what is 70 grams? 70 grams is 0.07 kilograms. Remember, how do we make grams into kilograms? We divide by 1000, so it means to carry the decimal point back 3 places to the left. So 70 grams is 0.07 grams. So what we'll do now is we'll add these items together. So 3 boxes, so we'll put that as 3 times 1 box is 3 boxes, and 0.5 plus 0.5, that's 1 whole. 1 whole plus 0.07 will give you 1.07, and this is equal to the total, which they gave us to be 7.7 kilograms. So here we have plus 7, so we're going to work backwards or reverse, and so if this is plus 1.07, we're going to minus that from 7.7. So 3 boxes is equal to 7.7 take away 1.07. When we work that out, which is not difficult, we'll get 6.63. So 3 boxes is equal to 6.63. So we must now divide 6.63 by 3 to find 1 box. And we will get 2.21 kilograms. And that's the value of Dina's amount of flour, because Dina is 1 box, and 1 box is 2.21. Last question on this page. Number 20. Cara ran 500 meters. Ariel ran 200 meters more than Stacy. The 3 girls ran a sum of 2.7 kilometers. What distance did Stacy run? So let's begin by converting the total into meters, so we can work all the numbers with or in meters. So 2.7, we multiply that by 2.7 kilometers multiplied by 1000, which means to shift the point 3 places to the right will give us 2700 meters. Okay, so Cara ran 500 meters. Ariel ran 200 more than Stacy. So let's put box for Stacy, seeing that Stacy got less. And for Ariel got 200 more than Stacy, so that's 200 more than box, so box plus 200. And now we'll add everything together to get a total. So we have 2 boxes, or 2 times box, and we have 500 and 200, 500 plus 200, so that will give us 700. And all of this is equal to the total that they gave us to be 2700 meters. So let's work this out. So 2 boxes is equal to 2700, because we added 700 Now we're going to take away 700 to get back the initial number. So 2700 take away 700 will leave us with 2000. So one box will be equal to 2000. Instead of multiply by 2000, we'll divide by 2000. So that will give us 1000. And they ask us for Stacy's distance, which we can see we have Stacy as one box. So Stacy's distance will be 1000 meters or 1 kilometer. They are both equal. meters or 1 kilometer. Numbers 21 to 25. At this point, you can pause the video, try the questions, and then resume the video. Number 21. Andy bought half as much milk as Trishana. In total, Andy and Trishana bought 5.7 liters of milk. How much milk did Andy buy? So who bought less? Was it Andy or Trishana? Andy, because Andy bought half as much as Trishana. So we'll use, firstly, let me copy this page. Make I have a separate page for the solutions. Right, good. So we'll use Andy as box, seeing that Andy got less. Trishana will be 2 boxes because Andy got half the amount of Trishana. So in total, that will be 3 boxes. Or like I like to put it, 3 times box. And this is equal to 5.7 liters. Right? We can't change this to milliliters. Right? To change liters to milliliters, we multiply by 1000 or shift the point 3 places to the right, and we'll get 5700 milliliters. So we can use either the 5.7 liters or 5700 milliliters. I will use 5700 milliliters because they ask us for the answer in milliliters. So 3 boxes is equal to 5700. So 1 box we must divide by 3. Three into 57 is 19. So Andy got 1 box, which is 1900 milliliters. Number 22. Kerry spent $30 at his stall that sold 3 pieces of dasheen for $10. Each piece weighed exactly 1 kilogram. He bought 2 watermelons that had a total weight equal to the weight of the dasheen. What was the weight of 1 watermelon? So $10 per piece of dasheen. So $30 will give us 3 pieces. 3 tens are 30. So 3 pieces of dasheen So 3 pieces of dashing for $10. So that will be 3 times 3, because we bought 3 times, or 3 sets of 3 pieces. 3 times 3 is 9, so that's 9 pieces. And each piece is 1 kilogram, so that's 9 kilograms of dashing. He bought 2 watermelons that is equal in weight to the dashing. So 9 kilograms is equal to 2. Let's put W for watermelon. So 1 watermelon would be equal to 9 kilograms divided by 2. So that will be 4.5 kilograms. Number 23. 4 books have an average of 28 pages. 3 of the books have an average of 29 pages. How many pages does the 4th book have? So the approach for this question is to find the total pages for the 4 books and find the total pages of the 3 books and minus the total of the 3 from the total of the 4 to find the amount of pages in the 4th book. How do we find the total amount of pages for the 4th book? Well, we multiply the average, which is 28, by the amount of books, which is 4, and we get a total. 28 times 4 is 112 pages. And we find the total for the 3 books, which is 29, the average of the 3, multiplied by 3. 29 times 3 is equal to 87. So if we subtract the 3 books from the 4 books, we'll remain with the amount of pages for that one missing book, or that 4th book. When we subtract this, we get 25. So the answer is 25 pages. Number 24. The average of 2 numbers is 18. 15 and x have the same average as the 2 other numbers. What is the value of x? So what we can do is we can find the total of the 2 numbers, and that will also be equal to the total of the other 2 numbers. So once the average of 2 numbers is the same, then the total of the other 2 numbers that has the same average will also be the same. So what is the total for the first 2 numbers? It is the average, which is 18, times the amount of numbers, which is 2. So 18 times 2 is equal to 36. So 36 is equal to 15 plus the missing number, which we call x. So 15 plus some number is x, so we can work backwards or reverse. So 36 minus 15 will give us x. 36 minus 15 is 21. So x is equal to 21. So your answer is 21. Okay, last question on this page. 3 numbers have an average of 21. 2 of the numbers are the same. The third number is 3 more than the first 2 numbers. What is the value of the third number? So for the two numbers, we'll use box. So the first number is box. The second number is the same. And the third number is 3 more than the other two numbers. So we can total that. 3 boxes is the, or we could write it as 3 times box plus 3. And they gave us a total to be, or they didn't give us the total. So let's work out the total. 3 numbers have an average of 21. So the total for the numbers will be 21 times 3. And that will give us 63. So 63 is equal to the 3 times box plus 3. 3 times box plus 3 is equal to 63. So we are going to work backwards. So we have plus 3, so we're going to minus 3. So 3 boxes is equal to 63. Sorry, 63 minus 3 is 60. So 1 box will be 60 divided by 3. We know 60 divided by 3 is 20. What is the value of the third number? So the third number is box plus 3, which is equal to 23. So the answer is 23. So don't forget to put your units. This one don't have any particular units. Number 26. Please try the question and then follow along with me for the solution. Number 26. The area between the pool and the perimeter fence is to be tiled with square tiles of side 2 meters. So this is the perimeter fence, and this here is the area between the pool and the perimeter fence. So it's the area going around the pool bordered by the fence. Okay, part A. How many tiles are needed? So the approach for this question is to determine the area of the pool and subtract it from the outer rectangle area. So first we have a square pool with an area of 100 meters. So the side of the pool, or the length of the side, will be the square root of the area, right? The square root of 100 is 10. We know 10 times 10 is 100 meters squared. So this side here is 10, and this side here is 10. They didn't give us the length and the width of the fence, but we can work it out. The length here is 10, and this additional piece here is 4, so that's 10 plus 4 is 14, plus 4 is 18. So the length of the fence is 18. And the width of the fence is 10 plus 2 is 12 plus 2 is 14. So we can use that to find the area of the outer rectangle. So area of rectangle is equal to 14 times 18. 14 times 18 will give us 252 meters squared. So the area to be tiled is the outer rectangular area minus the square area. So that will be 252 minus 100, and that will give us 152 meters squared. Now we are to tile that with tiles having a length of side of 2 meters. So what will be the area of a tile that has a side, a square tile that has a side of 2 meters? So area of tile, which we can work out mentally, is equal to 2 times 2, or side squared. That will be 4 meters squared. So the number of tiles is equal to the area to be tiled, which is 152, divided by the area of a tile. When we work this division out, we'll get 38 tiles. So that's the answer for part A. Part B. What length of wire is needed for the fence? So all we need to do is determine the length, or the perimeter rather, of the fence. So 18 plus 14 plus 18 plus 14. Right? Or some persons say the perimeter of a rectangle is equal to 2 times the length plus the width. Or we can say length plus length plus width plus width. We will get the same answer. So 18 plus 14, so that's 32. 2 times 32 is equal to 64. .64 meters of fence wire. Here we have the last 3 questions for this paper. Again, you can try the questions. Okay, let's go. Number 27. Betty's alarm was set for 5:45. She woke up 15 minutes after her alarm. Her alarm clock is 10 minutes slow. She took 40 minutes to get ready for school and 30 minutes to travel to school. The school bell rings at 7:30 a.m. Did she reach the school on time? How early or late was she? 5:45. 5:45 means 5:45, and that's a.m. She woke up 15 minutes after that time. So if we add 15 minutes to find the time she woke up, we will get 6 a.m. 45 plus 15 is 60. 60 minutes is 1 hour, so we add that to the 5. Okay, so her alarm clock is 10 minutes slow. So how do we get the correct time for the alarm clock? The correct time is 6 o'clock plus, so if it's slow we add plus 10 minutes. So it really should be 6:10 a.m. She took 40 minutes to get ready for school and 30 minutes to travel to school. So let's add those times to the time that she woke up. $30 plus 40 is 70 plus 10 is 80. So 80 minutes. So we can break that into hours and minutes. So we take away 60 minutes, which is 1 hour. We get 20 minutes remaining. So we add the 1 hour we took away to the hours column, and the 20 minutes remaining, we put that in the minutes section. So 6 plus 1 is 7, so that's 7:20 a.m. she reached the school. The bell rings at 7:30 a.m., so she's 10 minutes early. Number 28. So there's something that's missing here, so we'll put that in now. 2.4 hours in minutes. So sorry about that. And 300 minutes in hours. How do we convert hours to minutes? We simply multiply the amount of hours by 60, because 60 minutes in 1 hour. So 2.4 means 2 2/5. We can make that into an improper fraction by saying 2 5s are 10 plus 2 is 12. It's 12 over 5, and we can now multiply this by 60. 5 into 60 is 12. 5 into 5 is 1. 12 times 12 is 144. So that's 144 minutes. Part B. How do we convert minutes to hours? We divide by 60. Well, this is easy. Cancel 1 and 0 on top with 1 and 0 below. 6 into 6, 1. 6 into 30 is 5. So that's 5 hours. And last question. So a bit of information to start. The show Friends was 40 minutes long. We can see that the start time is missing, so hopefully that helps us. Part A. How long was the movie Avengers? And part B. What time did Friends start? So Avengers started at 9:45 a.m. We can assume that there was no advertisements or interruptions, and it went straight until 11:30. So 11:30 end time take away start time 9:45 will give us the duration. So part A, (11:30) minus 9:45. Now 30 cannot take away 45, so we must borrow from the hours, and 1 hour will come across not as 1 but as 60 minutes. 60 plus 30 is 90, so it's really 90 take away 45. 90 take away 45 is 45, and 10 take away 9 is 1. So that's 1 hour and 45 minutes. Part B. What time did Friends start? So Friends ended when Prince Dragon started. So Friends ended at 2:05 p.m. and it was 40 minutes long. So 2:05 take away 40. Now 5 cannot take away 40, so we must borrow from the hours. 1 hour is 60 minutes. 60 plus 5 is 65. 65 take away 40 will leave us at 25. 1 take away nothing is 1. So that's 1 hour and 25 minutes. Thank you for watching. If you have found this video to be helpful, please feel free to contact us for more information about our classes.